So my name is Alyssa, and I am going to go on to the original problem portion of my presentation, and the topic is speed of light. So I present to you my problem. A spacecraft is traveling away from Earth at a constant speed of 2 times 10 to the 7th power meters per second. At the moment, it is 6 times 10 to the ninth meters away from Earth, and it sends a light signal back to Earth. How long will it take for the signal to reach Earth? And how far will the spacecraft travel during that time? So, I have here, with the speed of light, the constant is c equals 3 times 10 to the 8th power meters per second. So the relevance of the question to the topic. This question is directly related to the speed of light because it shows how fast light travels over very large distances. Even though light is extremely fast, it still takes time to travel through space. This helps us understand why communication with spacecraft is not instant. The benefits of understanding how to solve this problem and the concepts in it helps show real world applications like how NASA communicates with spacecraft. It also helps build problem solving skills because we have to combine different ideas like speed, distance, and time. And this is important in both physics and engineering. So the process of writing this question, to create it, I chose realistic values for both the spacecraft's speed and the distance from the Earth. I made sure the problem required multiple steps, like finding the time for light to travel, then calculating how far the spacecraft moves during that time. So this question is unique because it involves two things happening at the same time. The light signal is traveling back to Earth while the spacecraft is moving away. And this makes it more challenging and helps deepen understanding of motion and light together. So this diagram helps visualize the situation. It shows how the spacecraft is moving away from Earth while the light signal travels back. And that makes it easier to understand the direction and motion involved in this problem. So we have one relevant formula, which is speed equals distance over time. And the constants for that is s equals speed, which we have over here, and then d equals distance, which is here, and then t equals time. And then we will also use the constant for speed of light, which again I'll tell you is 3 times 10 to the 8th power meters per second. And we use the speed formula twice, once for the light signal and again for the spacecraft. But yeah, the most important constant would be the speed of light. So this setup helps you recognize that both the light and spacecraft depend on the same time, which is the key idea needed to solve the problem. So for step one, we're gonna identify what you're solving for, which is the time for light to reach Earth and the distance the spacecraft travels during that time. We're gonna use the speed of light formula. So we're gonna do t equals distance divided by speed. And that's just a variation of our speed equals distance divided by time. So we were given the distance of 6.0 times 10 to the 9th power meters, and then the speed of light, which is 3 times 10 to the 8th meters per second. First, we find the time it takes for the light to reach Earth. We use the speed of light and the given distance that I just told you about. And then we divide these numbers and subtract the exponents because we're dividing, which which is going to give us 6 divided by 3, which we're going to get 2. And then we're going to do 9 minus 8, which is just going to give us 10 to the first power. So if you move this over one exponent to the right, because we have 10 to the first power, we'll just move our exponent one time, which will give us 20 seconds. So with our time of 20 seconds, we're going to take that and we're going to find how far the spacecraft travels. Since it's moving at a constant speed, we multiply its speed by 20 seconds. So we have the 2.0 times 10 to the 7th power times 20. And we're going to convert back our 20 to our 2 times 10 to the first power. So we can multiply these two easier, which gives us 2 times 2 is 4, and then we're going to be adding their exponents because when you multiply exponents, you add them. So that would be 10 to the 7th power times 10 to the first power, which just equals 10 to the 8th. 7 plus 1 equals 8. So then our final distance is 4 times 10 to the 8th meters. So the time for signal to reach Earth is 20 seconds, and the distance the spacecraft travels is 4 times 10 to the 8th meters. This solution works because it uses the constant speed of light, which does not change in a vacuum. The formulas we use are basic physics equations that apply to constant motion. Since both the light and spacecraft follow these rules, the answer is accurate. So overall, the solution is applicable because it relies on basic kinematics and the constant nature of the speed of light, making it a direct and accurate way to solve the problem. Another thing I would like to add is we rearrange the equation speed equals distance over time to find time, which is exactly what we need when we know distance and speed. So that would be another valid reason why the solution is correct. So one idea that is additional and valuable to the speed of light is mass energy equivalence. This shows that mass can be converted into energy, and the speed of light plays a major role in that equation. This idea is important in both physics and technology like GPS systems. I find it interesting how the speed of light affects time. For example, time can actually slow down for objects moving close to the speed of light. I would like to learn more about how scientists test these ideas and how they could be used in the future. In conclusion, the speed of light is a fundamental constant that affects how we understand space, light, time, energy. It plays a major role in modern physics and helps explain both advanced theories and everyday technology. So I chose this one source that was used in this project. It helped explain not only the value of the speed of light, but also why it is constant. It connected historical experiments to modern physics and showed how scientists like Einstein used these ideas to develop important theories. So this concludes my original problem portion of my presentation over the speed of light, and I hope you enjoyed. Thank you.